Let's look at this example in our notes. A particle moves with acceleration a of t is equal to 15 meters per second along an s-axis, has a velocity function v subscript to 0 is equal to -1 at time t is equal to 0. Find the displacement and distance traveled by the particle during the time interval from 0 to 2. Alright, so what am I looking for? I'm looking for the what here? Displacement and distance traveled, right? I know that for displacement, what do I need? The integral from t subscript to 0 to t subscript to 1 of v of t dt. I know for distance traveled from t subscript to 0, t subscript to 1, what do I need? The integral of the velocity function in absolute values, right? All right, so I do not have the velocity function, but what do I have? The acceleration function. So to find my velocity function to put here and here, all I have to do is integrate my acceleration function, right? So let's see. The integral of a of t. What is a of t? 15, right? What's the integral of 15 with respect to t? 15t plus c. That's my v of t, right? But what do they tell me here? They tell me that at time t is equal to 0, v subscript to 0, or my initial velocity, is -1. So what they're telling you is evaluate this at 0, when t is 0. And then this 15 times 0 plus c should calculate that initial velocity should equal to -1 in that case. So that means that c is equal to -1. So what is my velocity function? It's going to be this thing right here, but with a c value of what? -1. So this means that my velocity function v of t will equal to 15t. Instead of plus c, I'm going to put -1, right? So now that I have my velocity function, I can go forward and find these two things, okay? Let's do so. So let's find this part, my displacement here. My displacement is going to be the integral from what to what? What's my starting value of t? 0. What's my ending value of t? The 2 of v of t, which we just found to be 15t minus 1. So let's take our integral here. So this is 15 halves t squared minus t, and let's evaluate that from 0 to 2. From 0 to 2. Okay, now I'm going to have to erase some stuff up here. Let's evaluate that from 0 to 2. How do we do that? Well, you just say that's what? 15 halves times 2 squared minus 2 minus this function right here evaluated as 0. So minus 15 halves times 0 squared minus 0, right? So what do you get here? You get 15 halves times 4 minus 2 minus, what does all this go to? 0? All right, so let's see. What happens here? We get a 1 there, we get a 2 there, so that's what, 30 minus 2? What's 30 minus 2? 28. So I have 28, right? So what am I going to say? I'm going to say my displacement is equal to 28 what though? Well, I erased what we had up here. But then we have like meters and meters per second here. So what's the measurement of displacement? What are we going to measure displacement in? Meters. So my displacement is 28 meters. But what else did it want me to find here? Wanted me to find my distance traveled, right? Okay, so my distance traveled by my particle is going to be the integral from t subscript to 0 to t subscript to 1, which was from 0 to 2, of the absolute value of my velocity function. My velocity function is this, 15t minus 1. So let's integrate this part now, okay? All right, we saw in the last section how we integrate an absolute value, right? What do we do with this absolute value? We first have to rewrite it in terms of a piecewise defined function. A piecewise defined function. So let's see. Let's do that over here on the side. We're going to say the absolute value of 15t minus 1 is going to either equal to exactly what's in the absolute value signs, 15t minus 1, or the opposite of what's in the absolute value signs, negative, and then 15t minus 1. And remember your breakoff point? Where's your breakoff point? Where this inside is equal to 0? Well, you can solve this one in your head. That's going to be what? 1/15. So I'm going to write this. Now remember, if you're ever unsure about that, just do test values in here. Make sure it works out okay. All right, let's see. So what do I do with this integration here? I start at 0, but I'm going to break it up from 0 to what is going to be my upper limit of integration. This value over here, 1/15. 1/15. Plus the integral from where I left off here, 1/15 to what? What's my endpoint? 2, right? And which piece of the function do I use here for this absolute value? From 0 to 15, I'm going to use this piece, right? The negative, open parenthesis, 15t minus 1. Be sure you put your dt. Plus, from 1/15 to 2, that falls in this area, so I'm going to use positive 15t minus 1. Be sure you put your dt. All right, so what I could do is I could think of pulling this negative to the front here and take an antiderivative. What do I get? 15 halves t squared minus t here, right? And I want to run my limits of integration from 0 to 1/15. Plus, take an antiderivative here, 15 halves t squared minus t from where to where? 1/15 to 2. From 1/15 to 2. Now let's evaluate this stuff. This is a negative sign. 15 halves. Instead of times t squared, what am I going to say? Times 1/15 squared minus 1/15 minus, make this larger then, minus this antiderivative evaluated where? At 0. Minus 15 halves times 0 squared minus 0. Plus, let's evaluate this thing at 2, and then we'll evaluate it at 1/15. Plus 15 halves times 2 squared minus 2 minus 15 halves times 1/15 squared minus 1/15. 15 halves times 1/15 squared minus 1/15. All right, well, let's see what we get here. All right, so what am I going to get here? First of all, I can say, okay, negative goes here, right? So I have negative 15 halves times 1 squared is 1, right? What's 15 squared? Well, I don't know, so I'm going to write it as 15 times 15 minus 1 over 15. Okay? And why did I write this as 15 times 15? Because I saw it's going to divide out one of these 15s of that 15, okay? minus, what does this go to? That just goes to 0, right? Plus, what is this? 15 halves times 4 minus 2 minus, could I do the same thing here? Say that's 15 halves times 1 squared is 1. 15 squared can be written as 15 times 15 plus 1 over 15. Now where did I get the plus? Because I distributed what? That negative there. I wonder if I could write one more line below here. I think so. So what does this give me? This gives me -1 times 1 gives me -1 in my numerator. And then what do I have? 2 times 15 or what? 30 minus 1 over 15. Now I'm not going to write anything for that minus 0. All right. Plus, because I'm right here now. Now what happens whenever I multiply this? I get what? 30 minus 2 minus, this 15 divides out with one of those 15, so I'm going to have minus 1 over 30 plus 1 over 15 at the end, right? Now just go ahead and put that in your calculator. I don't care. Actually, you could have put this, but that would be a mess with all the parentheses in your calculator. And if you end up doing that, putting it all in your calculator, I don't want to bore you with details here. You're going to get something like 421 over 15. Now, if you put this in your calculator and you're using a TI 83 or 84 plus, after it gives you the decimal, hit math, hit the math key, enter, enter. So you can get the exact fraction, it'll give it to you. And what is this measured in? If we're measuring distance, it's going to be measured in meters for this example.